right, today we're in section 11.6, and we're exploring this concept of similar figures. For something to be similar, what do you think similar means?
Alike.
It means alike, but does it mean exactly the same? No, that's congruent. So there's a reason this lesson comes after 11.5, dilations. Because dilations create similar figures by operating within that scale factor, okay? It creates a similar figure. So similar figures are the same shape, but they're not the same size. So how do I know when they're similar? They can be obtained from another by a similarity transformation. That's similar to, okay, I don't mean to use the same word, but that's very close to the same thing as what we learned about rigid motion transformations. The only difference there was it was a rigid motion in that all the points were moving the same amount, meaning that it was not changing size either. But what's happening now is that all four of my transformations are on the table. It could be a translation, a reflection, a dilation, or a rotation. It could be any of them. So they won't always be the same size. Does not mean that they're not similar, though. So what we see in example 1 is we see figures. Well, in example 1, I don't know if they're similar or not. All right, so I have to somehow prove that they're similar. There's actually multiple ways that I could do that, but really the surefire way to make sure that you get it right every time is to compare corresponding angles. Okay, so we're going to compare corresponding angles in this example. What do I mean by that? I mean pick any angle, okay, in triangle ABC. So let's start with B. Angle B. Which angle corresponds with B? K. All right, K corresponds. So let's compare B and K. Well, the ordered pair for B is what? 3, 3. And the ordered pair for K? 6, 6. And my rule says that if this is a similar figure, that it should be able to be expanded by the same scale factor. We can tell that ABC and JKL are different sizes. So right now what we're trying to do is prove a dilation. Is there a scale factor that could get me from 3, 3 to 6, 6? What? By 2, right? K equals 2. But I can't stop there, because what if just one of my other points was a little off? Just because one pair of angles is corresponding and it has the has the scale factor doesn't mean they all do. So I have to test them all. A and J. So what's the ordered pair for A?
0, 3.
Yep, 0, 3. And what about J?
0, 6.
0, 6. Okay. What about C?
3, 3.
3, 0. And what about L? 6, 0. Does my scale factor of 2 work for all the other ordered pairs? Yeah, because 0 to 0, that doesn't matter. And it goes from 3 to 6. Yes. So yes, this is a dilation, but you must give me the scale factor. On your homework tonight, you must give me the scale factor, because the scale factor tells me you knew exactly how to measure this. You can tell just by looking at the graph that it's a dilation. But what if it was just slightly off? All right, that would be a problem. All right, let's look at the next set. All right, so it says rectangle ABCD. Determine if it's similar to EFGH. The sequence here is important because I can see that these figures are not facing the same direction. Would you agree? But I have to still be able to pick out corresponding points to see if any type of transformation could be happening between them. Okay? So let's just start with A. Okay, what's my ordered pair for A? -4, -1. And according to my sequence, because A comes first in the sequence, which angle comes first in the other sequence? No. Up here. Look here. See how A comes first? E comes first. So A and E are corresponding. All right? Well, I can definitely tell you one thing. This is not, well, and again, too, you have to see how the figures are turned, too. So it can't be a translation because the figure actually needs to turn. It's not a rotation because none of my rotation codes would make -4, 1 into 2, -3. None of them, right? They don't become different numbers. I just switch the order or switch the sign. A dilation wouldn't work. A reflection wouldn't work. So does everybody agree there is no transformation that could make point A turn into point E? Do you agree? Okay. So because of that, now we could just test another one. I think I tested a second pair, B and F, to come to the same conclusion. And again, because it has to be the same with all of them, there's no similarity between the two. This second method of determining similarity doesn't always work, but sometimes it can be a little easier. So I'm going to show you the second method too. It doesn't always work with, like, let's say, go back to the first one. When you have a hypotenuse or a slanted side, you can't really count units when the side is slanted. When it's a rectangle, it's pretty easy to count units. So how wide is ABCD? How many units? 2. So because I see that the other rectangle is also 2 units wide, that right there tells me they're not going to be similar. If anything, maybe congruent, depending how long they are. Well, how long is the first one? 5 units long. And how long is the second one? 7. So even when I'm comparing corresponding sides, that doesn't work either, all right? So especially when it's a rectangle, you can very easily compare corresponding sides, and that'll be helpful on the next slide. So corresponding angles and corresponding sides can be used to determine if two figures are similar, all right? Okay, so let's look at example 2 now. Example 2, the red triangle is similar to the blue triangle. Describe the similarity transformation. So here's the difference. I know these are similar. And the first one, I'm like, I don't know. I need to prove it with corresponding angles and sides. In example 2, I do know they are similar. I have to tell what transformation has happened to make the red one turn into the blue one. Okay? So some transformations have happened here. One transformation that's obvious from red to blue. Tell me the obvious one.
Dilation.
The obvious one is a dilation. And the second one's pretty obvious too. Probably some kind of a translation. I just don't know by how much. So what you can't say is dilation then a translation. Yeah, sure. But by how much? So you have to tell me the scale factor. Here's where corresponding sides are really going to help you. Because you can't compare the angles right now. Because they're different sizes. So really the only way to tell the scale factor of the dilation is to compare corresponding sides. That's where it's going to be really helpful. You already know that they're similar. So pick a side and pick the same side on the other figure, and how did they change? How many units wide is the red figure? How many units wide is it? 2. 2 units wide. 1, 2. How many units wide is the blue figure? 4. How do I get from 2 to 4?
Multiply by 2.
Okay, so the easy part here, dilation, K equals 2. Okay? I expect all of us to be able to get to that point, okay? So just pick a pair of corresponding sides. How do you get from 2 to 4? Multiply by 2. So my first transformation is K equals 2. My second one is more difficult, okay? Now the second transformation, I have a graph here, but this graph you're going to see is not really going to help me a whole lot. To figure out now, once I make red the same size as blue, I need to figure out the translation. Okay? So I'm going to pick any point on the red triangle. I'm just going to pick the right point. Okay? What is the ordered pair for that point?
7, 5.
7, 5. And I'm going to dilate that because y'all told me the red one's going to dilate by a scale factor of 2, right? So I'm going to dilate that ordered pair as if I'm making the red one the same size as blue. Y'all see what I'm doing? I'm going to dilate this point. So what happens when I multiply it by 2?
14, 10.
14, 10. So now, this ordered pair corresponds with the right point on the blue triangle. I have now 14, 10 means the red one is now the same size as blue. So now I can compare the translation between the corresponding points. Okay? So 14, 10 is the new right point. What's the ordered pair for the blue point that corresponds? 4, 2. So from 14, 10 to 4, 2, we need to describe this translation. What's happening to get from the right point on the red figure that's now the same size as blue to the right point on the point, on the right corner of the blue triangle? No, translation, guys. Left or right, up or down?
Left 10, and then down 8.
Okay. Left 10 and down 8. Does everybody see how I got that? Okay, so I'm going to say for the second one, it's a translation. Left 10, down 8. All right, so 2 transformations happen, dilation and a translation. All right, but I can't give you any credit unless you tell me how many units or what the scale factor is. Okay? All right, how do we do on that, guys? Okay? Not ready to take the test, but kind of following along? Okay? All right, so now let's look at the next one from red to blue. I at least want you to get the dilation. Work together. Okay? So we want to make it the same size first. So first we want to do the dilation. Okay? And then we can see if anything else needs to happen. Okay, so how tall is the red triangle? 2. And how tall is the blue triangle? 6. Now, if you compare the lengths, did anybody compare the lengths? Okay. How long is the blue triangle?
It's 9.
Oh, yeah, it is 9. Okay, and how long is the red triangle? 3. Okay, so it doesn't matter. From 2 to 6, what has to be my scale factor? 3. And from 3 to 9, what's my scale factor? 3. So I did both just to prove to you it doesn't matter which pair you compare. I can clearly see this is a dilation. K equals 3.
How's it 6?
Dilation K equals 3. So now that I have that done, now here's the challenging part. I need to pick corresponding, I need to pick any point on red, and I need to dilate it. And then pick the corresponding point on blue to see, maybe it'll be the same point and I'm done. I just dilate it. Maybe something else needs to happen. So pick any point on red and write your ordered pair and dilate it. Okay, I just picked the top one, 2, -2. If you picked a different one, it should still work the exact same. So I picked 2, -2. And I dilated it by a scale factor of 3 to get 6, -6. Okay? Now I'm going to compare that with the corresponding point on blue. Do y'all agree those are corresponding? They're on the top. Okay? Which is -5, up 5. Is that the same point? No. They're completely different locations. So, what type of transformation could move this first point to the second point? It's definitely not a rotation. Rotations can't move. It's a translation. It has to. So now it's going to shift. How many units left or right? How many units up or down?
11 left and 11 down.
How do you get from 6 all the way down to -5. 11 to the left. So this is also a translation. 11 left. And 11 up. Okay, and I did that by saying, okay, what do I do to 6 to get to -5? I would subtract 11. Okay, and to get from -6 to +5, I would add 11. This isn't in your notes, but it's very important. It's going to help you do number 12 on your homework. All right, so just pay attention. Just look up here. Okay, you don't necessarily have to write it down, but it's going to be on the recording. All right, so similarity. We dealt with this with ratios. Ratios can be similar, right? What about 3/6 and 5/10? Can they be both reduced to 1/2? Yes. So they're similar. So what we see here is a similar figure being described, okay? The painting versus the replica. So an artist draws a replica of a painting that is on one of the pieces of the Berlin Wall. This painting includes a red trapezoid, just so happened to be in that shape, the shorter base of the similar trapezoid, and the replica is 3.75 inches. So what is the height? So we're trying to find an unknown dimension, but we know that the figures are similar, which means that their ratios have to be the same. So what you're going to do, and guys, there's a lot of different ways you can set up a proportion as long as you compare the same thing on both sides. I remember that from our rates. I know it's been a couple chapters. So let's look at the painting. I'm going to say height 12/15, base. Height over base. If you look in your book, they did it different. We're going to end up with the same answer. Height of the painting over the base equals height of the replica over its corresponding base. 3.75. You guys remember your cross products?
Yes.
Okay, so cross products say 15 times h and 12 times 3.75. Okay, and you get 15h. Okay, equals 45. Now, how would I solve for h? Divide by 15. So that means that the height of the replica is 3 inches. Okay, so as long as your proportion sets out the same thing. Now, on number 12, you're going to see it's a model, and then it's the real thing. Just make sure you're comparing. In this case, I did height over base equals height over base. I had height on the top and base on the bottom. So as long as you do that on number 12 and set up your proportion that way, you will get the right answer. You might have different proportions, but you'll still get the right answer. All right, that's everything you need to know for 11.6.